Math Literacy, Linear and Exponential Growth, Lesson 8A. Linear growth is when a quantity grows by the same absolute amount in each unit of time. Excuse me. The same amount is being repeatedly added or subtracted. Example, the population of a city 50 people each year. The equation, y equals mx plus b. If you graph it, you get a line. X is the number of units of time, amount after x units of time. B is the starting. M is the amount that is being added in each unit of time. For exponential growth, when a quantity grows by the same relative amount or by the same in each unit of time. So if it's telling you what percent it's going up, that's going to be the same number is being repeatedly multiplied. It's exponential. Example, the population of a city increases by 2% each year. The equation is going to look like y equals ab to the x power. Y is the number of units of time. Number of units of time. Y is the amount after x units of time. E is the starting point. B is the number that is multiplied unit of time. Graph of linear equation. Linear is going to give you a straight line. Exponential, it's going to give you a curve. It's going to go up faster as you go along. So it's going up a little, and the further this way you go, the more you go up faster. We have equations to use for each of those. For linear growth, the equation is just that y equals mx plus b formula that you've known since junior high. Exponential, the formula is q equals q times 1 plus r to the t power. Q have after t units of time have gone by. Q0 is the initial amount. That's the beginning part. It's got that little zero. That's tell you it's what it is at time 0. R is the rate. That means T is the time. You're going to use that formula for exponential. Example 1. Starting in January of 2012, shelter has increased by 10 each year. If the animal population was 130 in January of 2012, what is it in December of 2016? Starting amount, 130. It went up by 10. So at the end of 2012, there was 140. You just continue with that process. Started out at 140 in 2013, 150 at the end of the year. You're adding 10 each time. In 2016, there were 180 animals in that shelter. Because we have added 10 each year. It's just gone up by the same amount each time. So each year, you're adding 10. 140, 150, 160, 170. 2016, there are 180 animals in the shelter. You know that's linear because it's going up the same amount each time. That is linear growth. The population of a town is 2,000. It increases at a rate of 3%. Automatically, you know that is exponential because they've told you a percent that it's going up. Determine the population in 4 years. Is this growth linear or exponential? We've already said it's exponential. If this town starts out with 2,000 people and it grows at 3%, then 2,000 times 0.03 tells you at the end of the year there's going to be 60 more people in that town. So there will be 2,000 people in that town at the end of that year. At the beginning of year 2, we're going to start 1,060 people. Now multiply, I do 2,060 times 0.03, which equals 61.8. We're going to round up because we can't have a fraction of a person. So we're going to say that that's going up 62 people. So 2,060 plus 62 tells me at the end of year 2 I have 2,122 people in this town. Continue on with this little process. At the beginning of year 3, you have 2,122 people. 2,122 times 0.03 equals 63.66. 63.66 is going to round up to 64. So we're doing 2122 plus 64 gives me 2186 times 0.03. This time it increases by 66. When I add that to 2186, I have 2,252 people in this town. So every time I am multiplying by percent and adding that's making it go up a little more each time. So that is exponential growth. This last example is about the value of a tractor is $50,000. The value depreciates at a rate of 6% per year. Determine the value of the tractor after 3 years. We know it's exponential because it's a percentage. If you multiply 50,000 times 6%, you get 3,000. It's depreciating, so I'm going to subtract that. This tractor is now worth $47,000. I multiply 47,000 times 0.06. I get 2,820. I subtract that from 47,000. The tractor is now worth $44,180. Multiply that times 6%. I get $2,650.80. Since this is money, I'm rounding to 2 decimal places. I do 44,180 minus $2,650.80. Value of that tractor after 3 years is $41,529.20.